Hello, Professor in class. This is week 7. We're supposed to be giving a demonstration speech. So the topic I've chose to demonstrate is the multimeter. I will be using the Sperry DigiSnap. This particular multimeter has the capability of measuring alternating current, or also known as AC voltage, which is commonly used in the household for your switches, your lamps, light switches, receptacles, and so forth. And it's also capable of measuring direct current, which is used in your batteries. This particular device here has the capability of checking resistance and continuity. The continuity and resistance check is also a very valuable tool in measuring fuses, checking wires to see if there's a break in the wire. It also has the capability of measuring current or amperage, which we won't be doing that today. We will just be checking voltage and the resistance of a light bulb. So to begin with, if you look at the front of the meter, you'll see common, voltage, and positive. When measuring with voltage, either AC or DC, you'll always have your black lead going into what's called a common. Black is always known as common, and then you will have the red lead inserted into the red V, or in V terminal. And here is your wires right here, and I will plug them into corresponding. So first of all, when we look at this meter, you'll see a couple of things. The first thing you'll see is a line with a couple of dashes, and you also see them with what looks like to be a wave. The line with the dashes is indicating that this is direct current or DC voltage. So we will use that to measure the batteries. Now, excuse me. Now keep in mind, there's only one range, so 600 volts. So we'll turn it to the 600 volt range. When measuring direct current with your batteries, you always want to take the common or your black wire, black terminal, and connect it to the negative side of the battery. So in this case, I'm going to connect this piece here to this section here, and then your red terminal or your positive will connect to the positive side of the battery, and we are reading 1 volt DC, and I'll show that to you guys. See, 1 volt DC. Now, because it is such a high range, I've decided to put 2 batteries together, which should give us about 3 volts if they are actually 1.5 volts apiece. And to do so, we need to make sure we have the positive connecting to the negative. The positive connected to the negative here, just like this. Now let's see if we can't measure 3 volts. And we are measuring 3 volts. So our batteries are good. Both batteries are good. That was the first thing I wanted to show you today, using direct current. Now we're going to change the unit to alternating current, which is the sine wave, or a wave. Now I am a licensed electrician by the state of Georgia, so I do not recommend anyone doing this. I recommend you have a licensed electrician to check any outlets that you may have problems with. Now, to make sure we don't blow up this particular device, it has a couple of settings. It has a 600 volt range, and then it has a 200 volt range. It's always, for safety reasons, best to use the 600 volt range first so you don't blow up the device. You never know if the outlet is going to have 120, 240, 480 volts on it. So it's always a good practice to start off at the high range, and then once you see that it's less than 200 volts, then you can step it down to get a more accurate reading. So try and get a voltage reading on this thing. There we go. And we are reading 124 volts. So we'll step it down and see if we can get a little bit more accurate reading. So it's actually reading 123.8 volts. So now we know that our outlet is good, and so we have no problems there. But have you ever had a light bulb that you think is good but you're not sure? So you'll take a light bulb out and you go get another light bulb, and playing swaptronics is what we call it. So here's a good way of checking this out. I have a light bulb here. Let's see if it works. So it doesn't appear to be working. So we're going to check the continuity between this point here and this point here, which is connecting the incandescent. In order to do so, we must change the wiring and the function. So you pull this red wire out of the V and you'll plug it into the positive terminal. Then you will change your function indicator to the 2K ohms, and you see that little, looks like a sound wave or a sound. It's just letting you know that it's gonna beep, or a sound's gonna come out if there's a direct short. Now, to determine to make sure this meter is working properly, we need to connect the two together to make sure that it is functioning properly. And we are not working at the moment. Let's see here. There we go. So we've just indicated that this particular meter, the wires are good. So we're going to connect one terminal to this side and the other terminal to this side, to the base. Light bulb's good. So that means there's no break in the filament in this particular light bulb, which is what causes a light bulb to go out. So we're going to plug this back in. Turned out the light bulb was not screwed in all the way, and that the light bulb was indeed good, and we have electricity flowing through there. So that wraps up today's demonstration speech, and I hope you guys were able to learn something from this. And I enjoyed sharing how this thing works. Thank you, and have a great day.